Right, 2.4 talks about exponential function manipulation. So this is more about uh, properties of exponents actually. So rewrite each of the following in the form of a times b raised to x, where a and b are positive constants. So uh, this is not a times b raised to x, right? Because it is, I mean, we can still consider that a is 1, but it is b raised to x plus something, which we do not want. We just want b to have only x on the top. So as per the properties of exponents, can I write 7 raised to x plus 2 as 7 raised to x times 7 raised to 2? Because eventually, if we reverse engineer, then the base is same and the powers are added, right? So you will again get the same thing. And all we have to do is replace 7 square, probably write 7 square first and then 7 raised to x, and then replace 7 square with 49. So 49 times 7 raised to x. So there you go. This is my answer, where this is a and this over here is b. So that's where we have manipulated. Likewise, over here, this can be written as 5 raised to x times 5 raised to minus 1. 5 raised to minus 1 can be written first. 5 raised to minus 1 times 5 raised to x. 5 raised to minus 1 will be 1 over 5. So 1 over 5 times 5 raised to x. And that's about it. I think we'll just box this in because 1 over 5 is a and b is 5. And finally, we have this, which is also pretty straightforward. It will be 2 raised to x times 2 cube. 2 cube can be written first. 2 cube times 2 raised to x. 2 cube is 8. 8 times 2 raised to x. This is our final answer. Right, more questions. I think this will be easy for you. 3 raised to x times 3 raised to minus 3, which is 3 raised to minus 3 times 3 raised to x. 3 raised to minus 3 is 1 over 3 cube times 3 raised to x, and 1 over 3 cube is 1 over 27 times 3 raised to x, which is the final answer. Over here we have, oh, this is, we won't do really anything with 2. 2 is just already, looks like a already. We'll just manipulate 4 raised to x minus 1 as 4 raised to x times 4 raised to minus 1. So this will become 2 times 4 raised to x times 1 over 4. And what is 2 times 1 over 4? Isn't that just, 2 times 2 is 4. So 4 raised to x is as it is, and this becomes 1 over 2. And 1 over 2 can be written right in the front. So it will be 1 over 2 times 4 raised to x. All right, and finally, this one is a little different because this one says that it is 3 raised to 2x. So 3 raised to 2x is like, because there's a property that if, exponent has two things multiplied, then it can actually be written as power of an exponent, right? This and this means the same thing as per the properties of exponents. So 3 raised to x whole square, and actually, you know what? I mean, although it is the same thing, but that's not going to help. But what will help us is if I write it as 3 square raised to x, because now I can replace 3 square as 9, and the power of x remains as it is, and this is indeed our form. You might be wondering, where is a? It is there. It's just 1, right? So a is 1 and b is 9. That's how it looks. All right, likewise over here, I'm going to apply the same strategy. So I'm going to rewrite this as 4 raised to 1 over 2 raised to x. 4 raised to 1 over 2 is basically square root of 4 raised to x. And square root of 4 is just 2. So this will be 2 raised to x. Over here, this will be 8 raised to 1 over 3 raised to x, which is cube root of 8, right? Cube root of 8 is 2 if I'm not wrong. 2 raised to x, so that should be our final. Whoa, both are same. Huh, interesting. Okay, and this one will be 5 remains as it is. 2 raised to 3x can be written as 2 raised to 3 raised to x. Uh, uh, 2 raised to 3 or 2 cube is just 8. 8 raised to x. So 5 times 8 raised to x. That's our final answer. Right, usually the following is an equivalent form of this one. So we need to probably either you can reverse engineer or you can, try to actually solve and get to the option. I'm getting a feeling that, of course, 36 is replaced, as you can see, with 6. So can we find a relationship between 36 and 6? I think so. because 36 is nothing but 6 square, right? So I'm going to replace 36 with 6 square and everything else remains as it is. And as per the properties of exponents, these two will be multiplied. So this will become 4 times 6 raised to 2x. And do we have that in the option? Yes, actually, yes, it is option D, right? 4 times 6 raised to 2x. Yeah, it is D. Yeah. Right, likewise over here, the 2x has been replaced with x in all the options, so that should be our aim. So I'm going to say that 5 times 3 raised to 2x can be written as 5 times 3 square raised to x. So this is going to look like 5 times 3 square is 9, so 9 raised to x. So it is 5 times 9 raised to x. And yes, bingo, that is actually B. Right. Over here, likewise, equivalent form, the x over 2 is getting changed to x. So that's what we should look for. So we are going to say that 9 times 4 raised to x over 2 can be written as 9 times 4 raised to 1 over 2 raised to x. And 4 raised to 1 over 2 is basically root 4 raised to x. And the square root of 4 is given by 2. So this will be 9 times 2 raised to x, and yes, we have that in our option. It is option B. All right, which of the following is an equivalent form of kx? Okay, so I can see that 4 is being replaced with 2 or 16. Can we find a relationship? Actually, yeah, I mean, 4 has a relationship with 2 and 16 both, because 4 is 2 square and or 16 square root. Let's try rewriting this as 2 and see if option A or B matches. I'm getting a feeling that, I mean, it's either B or D, because how can A square become A? But anyway, let's do that. Okay, so A square times 4 raised to x can be written as A square times, like I said, 4 is 2 square raised to x. So this will become A square times 2 raised to 2x, which is definitely not A or B, because it is 2 raised to x over 2. Another way to manipulate this, like we agreed, is A square times 4 raised to 6 can be written as A square times 4 can be written as 16 square root, right? 16 square root raised to x. This can be written as A square times 16 raised to 1 over 2 raised to x. And finally, it will become A square times 16 raised to x over 2, because those two will be multiplied. And which is right here, A square times 16 raised to 1 over 2 times x, or x over 2, that's the same thing. So that's our answer. So the following is the equivalent form of this. So we can clearly see that 3 is replaced with 9, and I do see a manipulation over here. 3 raised to negative 2x can be written as 3 raised to negative 2 raised to x as per the property. Negative exponent can be converted into positive by writing it as reciprocal. So 1 over 3 square raised to x. And what is 1 over 3 square? Isn't that just 1 over 9? So that's going to look like 1 over 9 raised to x, which is, yeah, fortunately, it's option D. That should be the correct choice. All right, last one. We have to find the equivalent once again. So, okay. Looking by the options, okay, it feels like, why do I feel like this is the answer? They have not really done anything special. We can see 8 times 9 raised to x over 3. So 8 is 8. And can I write 9 raised to x over 3 is 9 raised to 1 over 3 raised to x. And remember, cube root of 9 is not a nice number, and we don't want a calculator. We don't have a calculator here, so it's not a nice number. So definitely it's not going to convert into 3. Had it was square root, I would have said that, okay, square root of 9 is 3. So these two doesn't make sense, like A and C. Now, can I rewrite this in the radical form as cube root or third root of cube root is a better word, cube root of 9 raised to x? And won't that be option D then, because both look same?